Hello, my name is China Bouye. Today I will be doing my final exam presentation for MBA 6103. So the purpose of data analysis is to summarize data, make informed choices, and identify patterns and statistical significance within the data set. Data analysis tools that we can use are R and JASP, or Excel and Google Sheets. So Excel and Google Sheets is used for quick data like reporting or budgeting. It's limited in statistical tests, is not efficient with large data sets. It cannot produce publication-ready plots and graphs, and it does not have a scripting feature. So you must manually perform all analysis tasks in every spreadsheet. R is a better choice if you need to perform repetitive scripting, comprehensive statistical analysis, and work with big data sets. JASP is a better choice for publication-ready tables and figures. Exploratory data analysis for R and JASP. So R is a programming language used for statistical computing. It offers many different kinds of statistical analysis and plotting techniques. It's flexible with colors and themes. It uses data visualization packages to create graphs and plots. So for example, in this picture, you can see there's code, and then R is using ggplot for the graphs. JASP is a spreadsheet layout. It has a drag and drop interface. No coding is required. JASP can do many types of statistical testing. It automatically generates data in a clean document format, and it can also generate box plots, histograms, scatter plots alongside the statistical testing. So we can see that in this picture here with the descriptive statistics, and it also shows the box plots here. In JAS, they are grayed out and you aren't able to customize like you can over here in R. This is just another visual. These two have the same data uploaded, it just looks differently. So in JASP, you can see that it's more organized with the headers. And over here, you can just see that it's put in the code format and not very organized. So types of statistical testing. So ANOVA is a statistical technique used to determine if there are significant differences between three or more groups. In this case, we're looking at a repeated measures ANOVA. So repeated measures ANOVA is used when the same subjects are measured multiple times. In this example, we are looking at before, mid, and after therapy. The purpose of this test is to see if there are significant changes over time. Statistical significance is defined when p is less than 0.05. A p greater than 0.05 means that there is no significant effect. Eta squared is also something we want to look at, and that measures the effect size and will tell us if there is a small, medium, or large effect. Specificity is an important assumption in repeated measures ANOVA. It's important because of the variances of differences between all pairs of conditions or time points are equal. So we want to make sure that the sphericity test is showing that everything is equal. Violations of sphericity can inflate the F statistic and can lead to inaccurate p-values. And then we can also use corrections like Greenhouse Geyser or Hunfeld, and these can be applied when the sphericity is violated or not equal. And we can see where P is, so we want to look at the P. Over here, we'll look at the descriptor plot, so it'll show before, mid, and after therapy. We also have the p-value down here with assumption checks, and that's where Greenhouse and Huntfeld is. And then over here in the descriptives, we can also see like the mean before, mid, and after therapy. And up here, we also have the p-value. Another type of statistical testing is t-tests. So t-tests are used to determine whether there's a significant difference between means of two groups. It helps to determine conclusions about a population based on sample data. So here we're looking at summer and fall. So we can see here, it's a graph here that'll show us what it looks like, and then here the data up here to measure summer and fall, and then it also has the P here that we want to look at for significance. If P is less than 0.05, we will reject the null hypothesis, concluding that the difference is statistically significant. So modeling and interpretation, we're looking at linear regression. So linear regression is used to investigate the relationship between a dependent variable and independent variable. Linear regression finds the line that best fits the data points. We will still be looking for P, which is that statistical significance. We also want to look at R squared, which will tell us what percent of differences can be explained by factors in the models. Coefficients over here. So that will show how different factors change the test score. So in this case, we're looking at test scores, and we're looking at if education changes the test scores. We want to look at the intercept because that's the baseline score that we're looking for, or that it starts with. And then in this scenario, as college education increases, test scores also increase. And at the bottom, we can also look at the interaction. So this looks at how the effect of some college changes depending on whether a student is in school year round. Here, so when we do regression, it'll give us a residuals versus predicted plot, and it'll also give us a QQ plot. So the residuals versus predicted and the QQ plot are used to check assumptions of the regression. Residual and the predicted shows nonlinear patterns, and then the QQ plot shows if there's a normal distribution. So for the QQ plot, we can see that it's mainly on the line and that there's a few outliers here. So now we want to compare our strengths and weaknesses of R and JASP. So R offers many different kinds of statistical analysis and plotting techniques. It's flexible with colors and themes. It uses visualization packages to create graphs and plots like ggplot. It can be confusing for beginners. R uses memory and can lead to poor performance of crashes, and it has a large number of packages with overlapping functions, so that might become confusing for somebody who's new using R. For JASP, so JASP uses a spreadsheet layout and drag and drop interface. No coding is required. You can do different types of statistical testing. It does not have the ability to see R code as it writes, and it also does not have as many packages as R. So these photos here are just a different visual of what R looks like and what JASP looks like. We want to use R when we are working with large data sets, and then we'll use JASP when we want advanced analysis without coding. So conclusion, both tools produce reliable advanced statistical visualizations for data analysis and decision making. Using R and JASP allows repeated analysis multiple times. We can confirm results with multiple tests like QQ-plot and box plots. Depending on the skill level, JASP may be easier to use. R is more flexible than JASP with customizations. As far as exploratory data analysis, we want to use that to test the hypothesis, understand patterns within the data, detect outliers, answer questions about standard deviations, categorical variables, and confidence intervals. Right, these are all of the references that I used, including the modules and lectures from the course.